My name is Stuart Halloway, and we're going to be talking about Datomic Datalog. But I'd like to start first by just saying a few things about the conference. I feel that this is my first time at Philly ETE, and it's just been fantastic. I feel like that the organization has been just so well done at every step of the way. I'm particularly pleased that the organizers arranged for my alma mater to win the national championship in basketball last night. I feel like that was really gracious of them, and I feel bad for the Wisconsin team, but it was nice of them to do that. And that being said, they asked for a little bit more here too. So I've been speaking at conferences since 1990. Do we have the ability to make that? There we go. Since 1996 or so. So it's been a while. And usually, I get a conference, I submit an abstract to a conference and it's accepted, or I submit an abstract to a conference and it's rejected. But in this particular case, I got 2 or 3 rounds of feedback on the abstract for this talk and on what I should talk about today. And so there was a really, there was a lot of, and it was not just with one person, like the conference committee was like, really looking at this. And I want to tell you the gist of it. You don't have to go through the whole conversation, blow by blow. But basically the conversation was, Datalog is cool. So we'd like to hear about Datalog. And we'd like for the talk to be, get into some pretty advanced stuff, because some people are going to know Datalog coming in. But we'd also would like for the talk to be really introductory, so that if you were coming in and didn't know Datalog at all, you wouldn't be completely lost. The other thing that we would like is, Datomic and Datalog have been associated with Clojure, and Datomic's implemented in Clojure. And so a lot of people here already know Clojure, so we don't want you to waste a lot of time, explaining Clojure if that's part of the story. But on the other hand, we want to make sure that you explain Clojure, right, in such a way that somebody who hasn't been here before, or hasn't seen it before could do it. And so what we'd really like you to do is give a talk of all sizes and for all ages that appeals to young and old alike, and is both introductory and advanced. And I said, I'm a consultant, so I said yes. And so this is that talk. This is what we get. I'm going to grab my... This is my attempt to provide a talk that is introductory and advanced simultaneously, and assumes that you know a bunch of stuff and goes straight to interesting topics while filling in information as we go. So we'll see how this works. And I'll start by saying that Datalog is a query language. So this is going to be a talk about how to get information out of databases and how to do it well. And so we're going to cover, kind of the things you would suspect. We're going to talk about Datalog itself, right, which is a deductive logic-based query language. And we're going to talk about the kinds of things that make a query language pleasurable or usable. Obviously, you want your queries, well, I don't know. To me, it seems obvious that you want your queries to be able to join. Right? That's a big thing. If you come from the SQL world, it's kind of an expectation. It's also the case when you think about it, if you study like the relational algebra and you compare it to SQL, that to take a query language and then to turn it into something that's practical, there's a lot of things in query that are not actually about the logic. Right? The logic is really about unification and that sort of stuff. But you need to have extensions. So you need to have the ability, if you think about SQL, you can call functions. Right? And that's not just for making stuff, right? You can call functions just for controlling the results that are returned. You can have predicates, things like that. So we're going to talk about those things. And then we're going to talk about something that SQL doesn't have as much of, which is navigational extensions. And one of the things that I think about when I think about query is like half of the job of query is to find the entities you care about. And the other half of the query is to pluck out the details about those entities that you care about. But there's really not any logic in step 2. Right? Step 1, you've already won. You've got the entities in hand. Like if you think about it in a relational database terms, you've got the primary key of the things in hand. The rest of it is just kind of grunt work. But it's potentially interesting grunt work because it could involve navigation. And sometimes a SQL query is really complicated because there's a portion of the query that's doing the logic to find the root things that you care about, and then the rest of the query is using logic to do navigational stuff. Given that I have the order, also get the line items. And given that I have the line items, get the references to inventory, or whatever the other things are. But those are really navigational things. So we're going to treat that separately. Then there are things that in Datalog are particularly interesting. So disjunction and negation. And we'll talk about why those are maybe a little challenging in Datalog and what you can do about it. Then we're going to talk about chronological extensions. So one of the things that I've come to believe that you want in a database is to find out what happened in the past. And it turns out that databases are spectacularly bad at that because the traditional database is update in place. So it can tell you what's true right now, or at a lot of extra effort, you can build like shadow tables with timestamps and stuff, but it's not very good at that job. So that's what we're going to do. Let's start by talking about what Datomic is. Datomic is a database that's developed by my company, Cognitect. It's developed by some of the same people that developed the Clojure programming language and the Clojure script programming language. It has some characteristics that we feel create a niche in the world that didn't really have someone filling that niche before. And I think the NoSQL movement has really established that there are a lot of niches out there. And I think that I don't agree with all of the prime tenets of the NoSQL movement necessarily, but I think that the idea that there are a lot of different shaped problems and not all problems are shaped like a relational database is certainly one that has gained traction with a lot of people. So Datomic is designed for problems that are shaped like this. Problems that need an ACID database, right? That you want strong consistency guarantees. So this is something that you traditionally associate with SQL databases. But also powerful query, and that's what we're here to talk about really, is Datalog query. And then there's an interesting characteristic, which is the ability to distribute reads. A lot of interesting systems have the property that data is read more than it is written. Not all systems have that property, although you have to ask yourself why you're storing it, right? If you had a system that actually reads less than it writes, that means some stuff is never read at all. And so it doesn't seem super valuable to be storing it. And one way to sort of characterize these characteristics is that this is a database that's focused more at data of record and less at sort of dredging through junk. Right? This is not for like combing through log files and trying to find hidden gold. This is for storing the stuff you know is gold to begin with, right? The stuff that you want to have a good record of. Datomic has a universal schema, which means that it is extremely well situated for modeling data flexibly and allowing you to change your mind about what's important at query time. And this is one of the places where I think that even like the documentation of the NoSQL movement runs off the rails. Right? Because there's this notion of there are different kinds of databases like key value and graph and column and row. And that's kind of a disaster because I want a database that I make that decision in my query, not when I store my data. And so Datomic works that way and allows you to get access to data in all those different ways. And then finally, Datomic is indelible and time aware. What indelible means here is that when you put data in, it stays in there forever. And you can go back in time and say, what did the database look like a month ago or a year ago or whatever. Which again, this matters for a system of record system, right? If you're keeping track of money or medical devices or scientific experiments or a ledger and all those kinds of things, you want to know the history. And it may not be so important for something like some sort of big data scrubby kind of job, which is not suited for. We're focusing just on the query parts. So we're going to talk about query and schema and a little bit about the time-aware aspects. So what is Datalog? Datalog is it's one of two major academic branches in query languages. So if you go back to the 70s and 80s, the big idea was that we were going to use logic programs to get data out of repositories. And the idea that logic programs was going to be useful for this was really about, tell the database what you want, not how to get it. Right? That's a big idea in query languages. I don't want to say, go to this sector on a disk somewhere and find that, and then add it to this thing over there. I want to be able to say declaratively what I want and get it. And one of the primary ways people thought about that was a thing called the relational algebra, or the relational calculus. And that evolved, in some people's opinion, not very attractively, into SQL. The other one was Datalog. And Datalog, in terms of relative popularity, languished for a long time, but is now becoming more popular for reasons that we will talk about today. Datalog has a notion of rules for deriving new information. This is analogous in the SQL world to views. So you can create a perspective on information that knows things that were latent in the information already, right? It's not like in a certain sense, you haven't added new information, but in another sense, you have. And Datalog allows you to find facts from partial specifications. The way this is going to be visible to you is that Datalog feels like you're doing pattern matching. Right? You're going to say, I want to search for a tuple that has this shape, where I fill in the things that I want to hold constant and then ask the database to fill in the other parts. And this is super important. And one of the big reasons why Datalog is gaining ground again is Datalog works really well with object-oriented languages. And so for our example data set, we're going to use, and you don't have to be able to read this in great detail. You can look at the slides later. But the example data set is designed to be non-trivial enough to make you do stuff that would happen for real in a serious application. So this is the MusicBrainz database. The official open source version of this is hosted on Postgres, and we just took it from there and ported it. And we didn't port the full model, but just enough to sort of see here. And the big thing to note about this, the table summary here does not show the detail attributes. It only shows the join attributes, which is why some of the tables don't look like they have anything in it all. Right? They're just green boxes. But you have countries, languages, a couple of detail, genders, a couple of detail things. And then you have this knot of relationship that is a release of a piece of music, a medium, which is the physical instantiation of that release. Is it on a DVD or an 8-track tape or whatever? You have a track, which is a specific track laid down on a release. You have the artist, and then you have an abstract release, which I honestly can't remember why release is broken up into two things, but something we inherited from the model that this is taken from. And the point is, it's got a non-trivial join in it. It's got the kind of thing you would do if you were modeling data in SQL, not surprisingly, because it's an example that actually is done in SQL. So we're going to query against this database and learn Datalog. So Datalog is really easy, particularly in Datomic, because all the tuples have the same shape. This is what it means to say we have a universal schema. Right? A relational database has a different schema for each table. Right? Every table has a different shape. In Datomic, all data is in one shape. All facts are 5 tuples: entity, attribute, value, transaction, operation. And so to give you an example of that, Aaron loves pizza as of transaction 1100, true. That's a 5-tuple. And it tells us that at a certain point in time, it became true, or we came to know that Aaron loves pizza. And one of the things that straightforwardly falls out of that is obviously this supports being an indelible database, because if Aaron decides he doesn't like pizza anymore, we don't erase that record. What do? Now we add another fact, another datum, that says Aaron loves pizza, transaction 1450, false. Right? And so the database is a ledger that way, that you can see what happened and what changed. Against those 5 tuples, you're going to make specifications where you hold constant certain things. I want to look for everything that has a certain attribute, so the attribute piece was constant. Or I want to look for everything that was in a certain transaction, so the transaction piece was constant. That sort of thing. And then you're going to have, yes, question? So the question was, what does the op component do? No, the op component is 2-valued. Is it that this fact is being added to the system, or this fact is being removed from the system? That's all it does. Yeah, so it is a Boolean. And we won't see op for a while. Like, I'm mentioning it here for completeness. A lot of times when I give this talk, I actually lie. And at this point in the talk, I say that datums are 3 tuples, just entity, attribute, value. And you'll see why it makes sense to make that sort of squeeze of the truth at this point in the game. And that's basically how Datalog works. And then you have some technology that's up to you when you implement a Datalog to say, how do I put stuff in, how do I get it out? In Datomic, the things that are getting data out are called find arguments, and putting data in are called in arguments. And for the first couple of queries, I'm going to show you an incredibly tiny subset of the database that has only 4 facts in it. And the 4 facts are these. There is an entity that has an attribute release name, and that release name is Led Zeppelin. So that's the name of an album. And 42 is that release. There's another release, 43, that has a release name which is Led Zeppelin 2. And then both 42 and 43 have a value for release artists that point to 107. 107 is not shown here, right? This is an elided database. But presumably, what's the band name that 107 is going to point to? I made this one to be really easy. So 107 is the artist Led Zeppelin, whereas 42 and 43 are the releases Led Zeppelin 1 and Led Zeppelin 2. Now, the thing that's cool about having all your data in this shape is it directly translates to object-oriented programming. If I want to write this table statically typed OO Java style, here I go. Release 1.name is Led Zeppelin, release 2.name is Led Zeppelin 2, release 1.artist is artists, release 2.artist is artists. And that's exactly how you write Datomic Datalog, right? With object-oriented expressions like this. And so, if you had a match expression that was release.name, name, then name is being held constant. And so release name is the only thing we're going to find with that expression. We're not going to find artists. And then release, and we'll see this in a minute, is a variable that's going to be bound to 42 and 43. And name is a var that's going to be bound to Led Zeppelin and Led Zeppelin 2. So that thing, release.name name, is a specification. And it's a specification that holds the attribute constant, and at least as we can see so far, leaves entity and attribute free to vary, and specifies what we're going to get. And then here's a complete query built on that same thing. So this is a complete Datalog query. Find name, and remember a find argument says which thing to return. Later we're going to see more complicated queries where some of the vars are used only for joins. Right? So we don't actually want to return them. We just want to return some things at the edges. In this case, it's a trivial query. It only has release and name as vars. So find name where release.name is name. And the cool thing about this is that this translates directly to Java code. And you get all the benefits of Java's type system when you're doing this. So for every entity type in your system, you're going to have a type.v that represents vars that can take on that value. So a release.v can be a release, but not an artist, right? An artist.v can be an artist. And then you're also going to have vars. And one of the things you'll notice, and we'll go back a second, notice that values can be scalars, like strings, or values can be references to other entities. Test your knowledge. What table are those other entities in? It's a universal schema. It's one big table. Right? There's one giant table of quints, right, of 5 tuples that has all these things in it. But a value can be a scalar or it can be a reference to something else. So here I'm showing the OO Datalog syntax for a var that refers to some other entity, so release.v, or a var that refers to a scalar, var string. And when you're typing in your queries in your IDE of choice, you're getting all of the benefits you know and love of static typing. You're getting auto-completion that tells you here are the possible attributes that this particular type can have, and so on. So here is a complete end-to-end example of a query, assuming you already have a connection. So one thing to note about a Datomic database is because it's indelible, you can hold on to an immutable copy of it as long as you want. Right? It doesn't need to expire. Right? It just remembers what point in time you looked at it, and then if you go back and ask again, it still knows at that same point in time. So you don't actually talk to connections for queries, you talk to databases. So the first thing I do is I grab a value of the database at some point in time. Anytime I say con.db, that gives me the value of the database at that point in time. I can now sit around and think for half an hour and break my query into subqueries and do weird object-oriented iterative stuff. And then when I look at the database again, I'll still see that point in time and not things that have changed. Question in the back.
But it's not actually giving you like a copy of that database. It's just passing the time that you ask for the database to every query.
Right, so the question is, it's not actually giving you a copy of the database. It's giving you some sort of token that knows where you were. Well, I mean, I would prefer to say that that's an implementation detail that you don't have to know about. From a pragmatic performance perspective, all it has to do is deliver on the promise that if you show up later and want those pieces, that it can find them, right? That it can fault them into memory if they're not in memory or whatever. So let's leave that as slightly shrouded in mystery for now. But understand that this is trivial to do in an immutable system, right? Because the system is indelible, it's no difficulty for me to do that, and you hold on to that value and play with it as long as you want. All queries are fundamentally async because that's trendy. So when you call, and there's good reasons for it, right? With that, you can always build sync on top of it. But so when you call query client.q, passing in the query request, then you're going to get back something that's async. So that .get is a Java future get, right? Wait for the future, and you can put in whatever policy stuff you want right there. Timeouts and all the other kind of stuff you want to do. And then the thing that you get back is an object that knows about pagination and some other things I'm not going to show here. But it can also give you direct access to the value or to the first page value of the data that you have. And then that thing is a plain old collection of generic information, right? It's a collection of tuples. And this is really interesting, right? The thing that comes back is generic information, but you still get the benefit of static typing because the var name that you used here, go back to the previous slide, right? These vars get used in the query, right? They get used up here. And then you can use those vars as accessors into the tuple. The tuple itself is generic dynamic information. It doesn't know anything about those vars, but the vars allow you to superimpose, if I could stay on the slide long enough. The vars allow you to wrong way. Here we go. 1, 2, no. There. Why is it doing that? Now it's like lost. Oh, look at that. I didn't even know it did that. Okay, sorry. I'm learning how to use Keynote. When I said I'd been giving conference talks for 20 years, what I meant was I slept in a Holiday Inn last night. So, but this is a big deal, right? The query information that comes back from a query is generic information. You could process it in a totally dynamic, generic way, or whenever you want, and typically in Java you can opt into static typing and say, I want to have this, and this is going to tell me, I can only get out of these tuples the vars that I would put in. So here's a query for a constant value. So now notice that I have a var in entity position, but a constant in value position. So that's not going to find as much stuff. And then here you have a more idiomatic use, which is in arguments. Just as in a relational JDBC type scenario, you'd have parameterized query. You can have parameterized query by saying, I want to look for names, but I don't want to, hard code my query to look for Led Zeppelin. I want users to pass in Led Zeppelin at runtime. So here, find.in, $, we got this idea from prototype. $, means the database, just like $, means the universe in JavaScript libraries. So $, means the database. Find in the database some name where release.name is name, and then you pass in the database, which matches the first in argument, and the data input, which matches the second. Now, this is strictly more powerful than parameterized query that you're used to in like JDBC because, for example, you can pass more than one database. Right? So here I'm passing in one database and one string, but I could pass in 2 databases and 4 strings or whatever. And so you get cross-database join when you do that. So joins. Joins are a big deal. Joins are usually the thing that separate sort of wimpy query languages from stronger ones. And this is the place where the universal schema, having that flat 5-tuple space, really rocks your world. Because joins are really a pain. SQL's also meant joins, but it's also a pain because you have structural navigation. Right? You have to say, on this table, get this ID, and on that table, get that ID. And you have to say that again and again. So that's structural navigation. Or maybe if you're in a document store type scenario, you have nesting and containment. So imagine you're modeling this music thing and you're going to put it in the document store. What's the top of the document? If the top of the document is artist, and inside that is album, and inside that is tracks, what's easy to look for? Artists. What's not easy to look for? Has anyone been down this road? And every choice you make there is ugly. Also, it's sometimes the case that without a universal schema, you have directionality penalties. Right? If I'm navigating the relationship in this direction, it's indexed and it's fast. But if I'm navigating the relationship in that direction, it's not indexed and not fast. And so you get these sort of subtleties in how you're going to write your queries. So here's a join in Datalog. And joins in Datalog just fall out of repeating a variable. Right? You see that release is repeated twice. That means the release that matches on name has to be the same as the release that connects to an artist. And then you see artist appears twice. That means that the artist that's associated with this release also has to be associated with some particular artist name. This is a beautiful thing, so just bask in it for a second. Because what's the alternative, right? The alternative is something like that. If you were going to write a pure SQL DSL in Java, then it has all that structure in it. And an unsophisticated argument about this would be, oh, it has all that structure in it, but I could have a tool that automates that structure away. Right? I could have a tool that hides the details of that structure. What's wrong with that problem? What's wrong with that precept? A, that structure is not gone. And B, when you automate that structure away, you have to make decisions. Right? This is part of what people call the object-relational mismatch. Because I can model a relationship in an object-oriented relationship in 3 different ways in a database maybe, or 6 different ways, right? You have multi-table inheritance and linked tables and all kinds of different ways you can do things. You have to make all those choices and do them in a sound way. So it's not really just saving you typing that this difference is here. That's not really the important part. It's saving you from having to make decisions and having to make those decisions again and again. And that gets even worse as the things get bigger. So here's a real kind of query that you end up writing in a real system. It's not that big, but it's a 4-way join. So I'm joining track to artists, track.artists. I'm joining tracks to mediums, medium.tracks track. And what else are we joining? We're joining release to medium by release.medium medium, and then we're pulling out details of each. And this is all perfectly flat. What would this look like in SQL? You'd have to name 4 different tables, and you'd have to name 8 different join keys. And again, I'm not really making an argument about keystrokes. Right? I'm making an argument about decisions that you have to make as a developer and decisions that you have to maintain over time. Now, having said that, I started to write an example. I wrote the little example showing you where SQL gets more verbose doing this kind of job. I started to write the documents example, and then it just made me want to cry, and I gave up. So I will leave you to do that example yourself. But I would avoid documents as a database in all cases. They're really not suitable for much of anything. They don't have any power, and they're amazingly inflexible. And the reason is, ironically, because they make you make choices. Flexibility allows you to make choices, but having to make choices does not give you flexibility. Let's say that again. Building a flexible system may allow you to make choices, but being forced to make choices does not make a system flexible. And when you model something with documents, the first thing that happens is, I've got a relationship between 2 things. What do? I put this one inside that one. I put this one inside that one. I make this one have some sort of identity that references a thing over here, and then this one has an identity that references a thing over there. And which direction does the reference go? Is this direction of reference going to be efficiently navigable, and this one's not going to be? And basically what documents allow you to do, documents are like cubby holes. Right? If all you want to do is hide acorns and get the acorns back later, they're really great. But if your acorns have any structure to them, if there's any interesting thing going on, it's really poor. And this choice that you have to make has to get made again for every relation in your system. Right? Every time you hit a new relation, you're like, am I going to model this one on top of that one, or that one on top of that one, or with a reference? And, this is the biggie, queries must reference the choices you made. Queries must be written in terms of the choices you made. It's not like you get to make the choice, and if you make choice A, the query looks like this, and if you make choice B, the query looks the same way. What happens when you change your mind about these choices? Every query in the system changes too, and has to be changed. And, God help you if you need to query in a different direction, right? Just denormalize, right? We'll just start over and model it all again. So, that's the basics. Now, moving on beyond the basics, any query language has got to move beyond logic programming, I would argue, to do things that we have been taught to expect by SQL. And that includes things like predicates and aggregates. So, Datomic Datalog supports predicates through the op static class. So you can do less than, greater than, equal, or whatever, the kinds of the key predicates that you want to do. So this is saying, find the count of artists that started before some limit year that was passed in by the user. Right? The user says, I want to find all the artists whose careers began before 1950. And then op.less_than does the job. Now, we have played around with having this DSL let you say start year.less_than by making really fancy proxies on those objects, but it's not worth it. So, I mean, it gets too complicated, and even if you can make that work, what happens is that IntelliSense ends up blowing up because you end up having 400 possible methods on an object, which is not really doing you a lot of love. So this it's not super beautiful. I'd prefer to write start year.less_than limit year, but I think this is the best compromise you have in Java land at least. Likewise, you can have aggregate expressions. So here, I'm joining on artists and releases to find all of Paul McCartney's releases. I'm going to find the artist whose name is Paul McCartney. I'm going to find the releases by that artist, and then I'm going to find those release names. But then I don't actually care about the values. I just want to get the count. And so in your find expression, you can say, give me the count of releases. And then in order to refer to that down in your answer, you can assign that to a var with as. So you can have a release count var that, again, is a var of long. Right? It's a generic. It's a var of long. And again, the Java's type system is going to protect you from a lot of errors here. Right? So it's not going to let you assign to a var of the wrong type. You can't put it in int result in a string, those kinds of things. But also, like building up this query is all going to chain sensibly. After you say find, you can say in, but then you can't say in again. Right? So the fluent DSL is stateful, right? It knows, oh, I said in already, I can't say in again. Or I've said where once, I can't say where again. Those kinds of things. All right, so now we have, conceptually at least, we're kind of close to parity with SQL. right? We have logic, we have joins, and we have functional extensions to do predicates and aggregates. And we have a really straightforward Java syntax for getting to all that stuff. The next thing, and this is an extension, this is not part of Datalog, are what are called pull expressions. And the idea behind a pull expression is I already have an entity in hand. Right? I know I have Paul McCartney. And now I don't want to do logic programming, I just want to navigate. I want to do the kinds of things people do in graph databases more often. And so what this lets you do is you do the finding of entities in Datalog, and then in your find expression you can pull specific attributes that you care about. And the pull includes wildcards, so it's commonly the case in a program that you're like, it's just like select all of a row in SQL. I want to get everything about Paul McCartney, or I want to get everything about Paul McCartney's album. There's also some support in pull for doing a recursive pull if you have, I want to get friends and their friends and the friends of friends and something like that. So this is what that looks like. So notice that the find expression now does not just return raw vars, it actually pulls particular attributes. So I say from the artist pull start year and end year, and I want to know everything about the release, so just pull all. And then when I'm actually consuming my results, now I have the .e types. Before we saw the .v types. So artist.v is a var that can be bound to an artist. And release.v is a var that can be bound to a release. These are entities. These actually represent the found things with typing. So notice that once I have an artist.entity named A, that I then get typed accessors. And again, this is quite interesting because the underlying stuff is all dynamic, right? It's all iterators of tuples, which are just generic collections. But the type magic is superimposed. So you can say, so it's actually in the call to tuple.get. Tuple.get knows that artist is an artist. And so instead of returning a generic map of information, it returns an artist.e. All right. Now, an academic would tell you the following thing. SQL plus recursion has equivalent power to Datalog plus negation. And so if you want to go, that's just academic, right? Obviously not all query languages are created equal and they have different performance characteristics and whatever. But if you just want to go sort of checkbox feature by checkbox feature, then if you had a Datalog with negation, that would give you equivalent power to SQL plus recursion. The other thing that they would tell you is that rules in Datalog are the path to disjunction. They're the path to OR. So everything we've seen so far has been and, right? If you think about those query expressions, it's the artist has this release, and the release has this. All those things have to be simultaneously true. You also end up having queries that you want to have OR in them. You're going to say, if this is true, or that is true, right? If it's an 8-track tape or vinyl, I'm interested, but I don't care about CDs. Those kinds of things. So, Datomic's Datalog does support rules, which is the traditional way to get to disjunction, but rules are also an abstraction mechanism, right? They put the stuff over there. So it's like you got to go make a thing over there just to do OR. And so it'd be nicer to just have OR be available directly and in line. And so one of the things that we've added in 2015 is just OR clauses that just nest inside of where. So now, and you can read anything without an OR as an implicit and, where artist.name and either the artist is from the US or the artist is from California, or Canada. That's because California is clearly not part of the US. That'll be true after the water riots, but not yet. So this is more interesting. I mean, it's nice to have this capability. You can do disjunction with rules as well, but it requires more effort and it requires you to do things in two places. Where rules really shine is for actually deliberately having that separation, right? I want to create a reusable chunk of logic, right? These 5 join clauses appear in 6 different queries, so I'm going to put them in a rule. But where you want a simple OR, you can just do that this way. Likewise, you can just do negation. And the important thing to understand about the way Datomic's negation works is that you think of it as subtracting from tuples you already have in hand. So this says, find all the artists. And by the way, this is the first time we've seen artist.name without an argument. So now we're not binding a var to all the names. We're just saying, give me all the artists. And then remove from that match the results of this other match. So take all the artists whose country is the United States and take them out. Because we're tired of American music. We want to be more broad-minded and listen to something else for a while. all of this is built on a set of indexes that do not require you to make choices. So the way to read these indexes, AVET, the acronym is attribute, value, entity, transaction. And what this shows is that with the right set of indexes, you don't have to decide if you're a row store or a document store or a graph or a column store until you make your queries. Right? A lot of the NoSQL movement is about, go and pick the right shaped database for the queries you want to ask. I want to put my data in and then decide what queries I want to ask. And I want to have indexes that make doing that straightforward. And so if you think through how these work, you'll see why it makes sense. So each one of these supporting indexes is sorted by left to right. So the AVET index means sort everything by attribute. So all the first names are together, and all the last names are together, and so forth. And then by value. So the AVET index is suitable for looking things up by name-value pairs, which is what key-value stores do. Right? It's actually more general than what key-value stores do. But this is, find me everyone whose name is John. Find me everyone whose name is Susan, that kind of thing. EAVT is entity leading. So this doesn't keep all of the attributes together. This keeps all the facts about a particular entity together. So this supports doing the things that relational databases are good at. Right? Tell me everything about this order. Tell me everything about this release. Tell me everything about this track or whatever. AEVT, column leading, is what column stores do. I want to run through all the prices in the system or all the money in the system and make sure it tallies, but I don't care who has the money. Right? So it would be crazy to go to an entity index. It would be, I don't need to look at all the other information about the entities and skip past first name and last name and whatever. I just want to look at the balances and make sure they add up. Document stores also primarily are about entity leading stuff, right? They're about starting from an entity, what can you find inside that entity? And there's some more things that we do there that I won't get into now. And then graph databases are about being able to navigate relationships. Well, if you have an entity that's related to something, then any E leading index, you're good, right? Because you've now found Paul McCartney, now you can find Paul's stuff. But what if you have Paul's stuff and you want to find Paul McCartney? Now you want to go in the other direction. You want a value leading index. And so value leading indexes, VAET, are created only for reference types. You don't need them for strings, right? Well, you might want them, but you're not going to get them, right? So there's nothing, if you had a value leading index for strings, you could say, find me all the Johns in the system, whether John was the name of a song or the name of a person. So it's not optimized for that scenario. But you could find all the Johns that were people or all the Johns that were songs, but not both in one go. So this is really powerful because it's a terrible thing to build a system that's good at answering the kind of questions you need to know today, because what can you be quite certain of in any successful system? You're going to have to answer different questions in the future. The other thing that's nice about this, and this is actually something that's evolved over time, so people who have been in previous Datomic talks, all these indexes, we are moving towards a world where all these indexes are created automatically. Right now, AVET is not. So AVET is one that you have to explicitly request. But we hate that. We hate that about SQL, like having to get your basic system to work, having to specify which indexes, and if you don't do that, it doesn't run well. So we are moving, and there will be a future release of Datomic that does AVET automatically as well. And the reason for that is that in the early implementations of Datomic in 2011 and 2012, it was expensive algorithmically to produce AVET in a way that the others are not. And if you think about it, it makes sense, right? Because it's by value. So things come in, the values like, it's not the case that the first year you run your business, people named Alfred show up, and the second year people named Betty show up, and the third year people named Carlos show up, so they're all sorted, right? But it is true that if you're assigning entity IDs yourself, that they do actually increase over time. So AVET is the hardest index to calculate, and so for performance reasons, it was not originally turned on by default, but it will be turned on by default in the future. And that gets us to a world where all of this works out of the box without having to make any indexing choices at all, which is nice. Now, everything we've said so far has been living in that little world of a lie where it's just triples, not quints. Right? All of our queries so far have been entity, attribute, value. But it's a big part of the proposition of Datomic to be able to keep track of time. And so when you start to consider the last two parts of the tuple, transaction and added, this is what makes the database accumulate only. Right? You accumulate information, and all the old information is still in there. This used to be true, and then you have another datum that retracts it to make it false. And now you have two datums in the system. And the way that this works from a user perspective is that on a database object, you can call for different filters. By default, the database shows the current state of the world, everything that's known to be true right now. But you can say .as of, and that time travels you to the past. You can say .since, and that removes the past. So show me only things that became true in the last 2 weeks. The transaction report we won't talk about right now. You can say .with. This is traveling to the future, which is really cool, right? So what .with does says, if we added this to the database, what would be true? So you can pass in a bunch of new data and see. And then .history says, give me a timeless view of everything. Give me a panoptic view where all things that, that have ever been true are visible. And sometimes it's hard for people to sort of visualize this, so I have some really tiny print that'll help you in a second. Visualizing it. Using it from code is incredibly easy. So let's imagine that you built a system and it can answer, you've built a bunch of queries and they can tell you the truth of the world today, and your business stakeholder comes back to you and says, I want you to tell me what the data looked like a month ago. What do you do in a traditional system? Go to backup, right? Or start modeling time inside your own data model, like starting adding like created at and updated at attributes. But even when you do that, you have to write a different query. Right? Querying for the present has this shape, and querying for the past requires touching attributes so you don't otherwise touch. The nice thing about this is your query doesn't change at all. Right? You wrote a query that knows how to, and I'm not even showing what the query is here. And all you have to do here is say database.as of and travel back in time. Or database.since and shear off the past. Or database.with and add some speculative stuff into the system. And here's how it works under the covers. You don't really have to be able to read all of this, but this is just a quick walkthrough. This is a database with 5 transactions in it. This transaction said that we have an item in inventory, dilithium crystals, and there were 100 of them. Then the second transaction says, nope, we don't have 100 anymore, we now have 250. Then the third transaction says, no, we don't have 250 anymore, we now have 50. And then the next one says, oh, we don't have 50, we have 9,999. But then somebody went back and added an attribute to that transaction saying it was a mistake. So that's marked as error true. And then we go back from 9,999 to 100. And once you visualize that this is how the data is stored underneath, then you understand how you would implement as of and with and these various things, right? The way that you implement the present is you have a filter that just screens out anything that's no longer true. So, right, the current value, the current number of dilithium crystals in the system is 100, and all these other points in time are history, so they're filtered out. The as of filter goes back in time, so a bunch of recent stuff is filtered out, and then you get to see back at the point in time when there were 250 dilithium crystals. And the since filter is just the opposite of that, right? It shears off the past and then applies the normal filtering on a go-forward basis into the present. And then the history filter says, I want to see everything. Just show me the, And this is useful for producing like a report, everything that ever happened to an entity, or everything that ever happened to a package, or everything that ever happened to a customer account, those kinds of things. You can also query for transaction. So as we saw before, artist.name Paul McCartney, that's entity attribute value. But you can now extend that with just chaining on another method, entity attribute value.transaction. And then the transaction itself is a first-class thing in the system. It's an entity in the database with an entity representation, just like entities that you make. Its type is in the DB namespace, which is controlled by Datomic, right? That represents entities that are part of Datomic's sort of foundational schema, which includes the instant at time in which something happened. So this says, tell me when the system learned that there was an artist named Paul McCartney. And then you can join on the transaction, right, just like anything else. So we're joining on the transaction that we found here and then finding out the instant and time that it happened. A useful note for people who are super excited about this time travel thing, Datomic maintains 2 notions of time. There's the clock time, which is tx instant, and then there's just an incrementing counter, which is called t. Why do we need both? Because we can't presume 2 things don't happen at the same instant. So you can record that 2 things happen at exactly the same instant. Then they're indistinguishable by wall clock time, but they're still distinguishable by the incrementing t count. And all the APIs that work with transactions can take either one. So they have a signature that says you can pass in the number or you can pass in the time. Yeah? So Datomic is a single writer system. So the clock that's used is the clock of the single writer. And it is a very good idea to make the clock on the single writer. I mean, it is your transacting box, right? It's an important thing. But it's a good idea to make that clock accurate for that reason, right? Because you have to pick something somewhere. But one of the things that, well, this gets more into operational characteristics. We can talk about that at the end. But yeah, Yeah, there's a box called the transactor, and its job is to record all transactions and to assign that ascending T order, right? And then that's all super easy to do because it's the only box in the system that does that. And that box doesn't do anything else. It doesn't have to service reads, because once you have an immutable database, why would you read from the same process that you wrote from? Right? It becomes not a problem. So, where are we? I think this is a bit of a manifesto for how databases and queries should work. We have seen a query API that's powerful, as in you're not giving up a lot of the kinds of things you lose when you go away from SQL. It has unification, it has joins, it has aggregates, it has predicates, it has disjunction and negation, and it even has navigation, the ability to sort of think about navigation from entities separately from the logic part of your query. It's flexible. You don't have to decide when you put data in your database how you're going to get it out. As a result, queries are flat. You don't have all the navigational structure in your joins, and you can choose to use row-oriented or document-oriented or graph-oriented patterns for accessing your data. And it's indelible and chronological. It's a database that remembers the past, and it's rendered directly in your programming language. If you like OO, and today's version is Java, so I don't necessarily promise every programming language yet. But if you like Java, it's rendered in your programming language. Now, anybody who's ever seen any other Datomic talk want to say what's weird about everything I've said so far? Yes?
You seem to have a positive view on a type system.
Oh, let's not make it all personal. I have a slide that will address that. But regardless of my personal views on type systems, the thing that's missing here, if you've ever watched any of the other Datomic conference talks or the people who have given talks here in the past couple of years, is that every other Datomic talk ever has the queries written as S expressions. Right? So the queries are written in the extensible data notation, or ETE, as S expressions. And so the question is, where did all this Java stuff come from? And the answer is really cool. It turns out that static typing is icing and dynamic typing is cake. And this is the way a lot of real-world big systems get built. Right? The underlying substrate on which the systems are built is dynamically typed, it's made out of data, and then you meet people in their language and you take advantage of the power of their language in their process. And so this whole Java DSL has a method called .asData that returns a map or a list of maps, which is the actual raw underlying pure data representation that goes on the wire. And this pure data representation, this is actually ETE syntax. So this is what this looks like in ETE. But you see this pattern again and again. Another good example of this pattern, although I don't love their DSL, is anyone who's ever consumed Amazon Web Services from Java. Right? There's a whole static type thing, but as is often the case with those things, it's programmatically generated from data. Right? The underlying thing is actually, I don't know, WSDL or who knows what, right? Their XML. It's a data-driven specification. So tying this to what people have said about Datomic in the past, this thing is all brand new. So this talk has been all about icing. And in fact, I will just disclose now that since I was commanded to talk about the past and the future, that this DSL is still a little bit in the future. So the Java DSL is not released today. It will be released in the coming months. But what you saw today is icing, still in the kitchen. It's not actually been served yet. But if you want more dessert, you got two choices. If you want to know more about the icing, I'm going to stick around after the talk, and we can open up IntelliJ IDEA and look at it, and people are interested, whatever. Or if you're more interested in the cake, that stuff is documented to death. There's like 500 videos of showing the database, the data-driven syntax for Datalog, and I've linked here to both the docs and the video. So if you like what you saw today and you want to use it right now, you're going to have to use it with S expressions in ETE. And the instructions for doing that, you can read straight through that query document, and it goes point by point through the same stuff we did today, but you just won't see any Java DSL anywhere in that. The other thing that's really cool about this is it's a great example of layering in software. How much of the cake did we change to put the icing on? None. Right? Cake is the same as it's ever been, and you can continue to use it. So with that, my stuff's up here. You can reach me, Stuart Halloway, on Twitter or my email. You can look at my other presentations, and we'll take a few minutes for questions. Aaron.
How much does the icing cost?
How much does the icing cost? The icing, when it ships, will just ship with Datomic. There's no
I mean, as far as
performance.
yes,
Doesn't.
garbage characteristics, that kind of thing.
Yeah, the icing does very little, right? It's the icing is a So the question is, how much does the icing cost? The icing is a real internal DSL interpreter, and it's negligible compared to doing the query itself. So yeah, the icing is not a problem. Other questions? Yes?
Do you guys have any plans to do a hosted Datomic service?
So the question is, do we have any plans to do a hosted Datomic service? That is a question we get very often, and we are thinking about it, and we are going to do something about it, but what we're going to do about it is not going to be exactly what you would expect, because we're all about pulling rabbits out of hats. But we are going to do something that would address some of the things that points to. Yes?
Hi. I've been curious about using Datomic either for like open source or personal projects or experiments at work, but scared off by like the licensing fees. How far could I realistically get before they became a problem?
So there are 3 tiers of Datomic. They are designed to address different needs. There's a commercial tier where you pay money, and it's not super cheap. And that's how we stay in business and how we keep making it. And then there are 2 tiers that are free. There's the starter tier. The starter tier gives you all of the functionality, but doesn't scale out horizontally as much. And we actually have, serious enterprise work that would fit inside starter, right? It's quite capacious. And then there's also free. The difference between free and starter is that it doesn't have all the features in terms of storage and direction and so forth, but free is redistributable. So that's actually a big deal. It matters as much or more that as something being open source is being able to redistribute. And so people that are building open source things on top of Datomic typically target free, and then it is A, free as in beer, but it's also B, redistributable as in you don't have to interact with us or anybody else to embed it or use it in your own thing. So you sort of have 2 choices. I think if you're building an open source hobby project, use free. If you're test driving something and you don't want to get budget permission until you see it work, then you use Pro Starter. And then for production, you use Pro. Oh, I should say, you can use Pro Starter in production as well. So you can, I'm sure more than half of our users are in production for free right now. But we don't know who they are because they don't pay us. One more question, and we'll break. Or not. All right, thank you.